And tan and young and lovely, the girl from Ipanema goes walking, and when she passes, each one she passes goes When she walks, she's like a samba that swings so cool and sways so gently, that when she passes, each one she passes goes so sadly. How can he tell her he loves her? Yes, he would give his heart gladly, but each day when she walks to the sea, she looks straight ahead, not at him. Tall and tan and young and lovely, the girl from Ipanema goes walking, and when she passes, he smiles, but she doesn't see.
Surface tension is caused by the cohesive forces between water molecules. This happens because water molecules are polar, meaning there is a slight negative charge on oxygen and slight positive charge on hydrogen, thus allowing for hydrogen bonding between water molecules. Molecules on the surface don't have neighboring molecules, so they'll adhere more closely to each other to form a bubble. But what about viscosity? Originally, we thought viscosity would play a role in surface tension, but it didn't. Let's start by defining viscosity. Viscosity is a liquid's resistance to shear stress. You think that if a liquid resists shear stress, it means that the molecules are more closely bonded to each other. This is not the case for this experiment. The relationship between viscosity and shear stress can be described by this equation. But in our experiment, our liquids were at rest, so viscosity is irrelevant. Water is polar, which allows it to interact with other water molecules through hydrogen bonds. Viscosity cannot be related to surface tension in this experiment, but that's because viscosity is measured by a liquid's resistance to shear stress, which requires velocity. So the difference in surface tension between our liquids are caused by the various compounds in our solutions that strengthen or weakens the bonds.